I just want to share with you another way, if you had not thought, to use the recurrence tree of solving this recurrence, and this is a technique which is essentially unrolling the recurrence. So here, let's start with the Mergesort recurrence. So we have t of n is equal to times our recursive calls on the list of size n over 2, so we're making 2 recursive calls on size n over 2, plus the work that we have to do for the merge, which is just linear time for the merging of the portions of the list. Now, what I meant by unrolling is that now we can apply the recursion itself recursively. So here we can rewrite t of n over 2 as 2 times t of n over 4 plus constant times n over 2 plus t of n. Then we can unroll it again. And here we would get 2 times n over 8 plus constant times n over 4 plus c n over 2 plus c n. And you'll notice that we are developing a pattern, and we just have to consider for a moment what that pattern may be. When we consider the pattern, we notice that it's just 2 to the k times t of n divided by 2 to the k plus k times t times n. And now we have to think carefully about when will this recursion stop. So k is the number of recursive calls that we're making and the depth of the level, and we've already seen that the most number of recursive calls that we can make is log 2 of n, and the reason for that is we'll hit the base case. So what I mean by that is, how can you actually figure this out when this recursion is going to stop? So we want to consider we hit a base case for t of 1, so we want to figure out what is the value of k such that n divided by 2 to the k is equal to 1? Well, we know that since n is equal to 2 to the log 2 of n, then k is equal to log 2 of n. So now we can just go ahead and do the substitution. So let me do that. So now we would just have n, so substitution, so let k equal 2 to log 2 of n, and now we're just going to substitute it here. So we're going to get that 2 to the log 2 of n is just going to be n plus, well, we just have to do one thing. I'll do one more substitution. We'd have t of 1 here, because 2 to the log 2 of n is n, so n divided by the n is 1. And then we're just going to add in log 2n times a constant times n, and we know that for the base case we're just doing a constant amount of work, so this means we're just doing n times some constant plus log 2 of n times c times n. And now we have this in a closed form. It is only expressed in terms of constants and n, and we can see that this is n log n. So that is another way to deal with this recurrence directly.